Hello everyone. Today we are going to present on a topic called one-time pad implementation with key generation, which is a part of cryptography and network security. This project focuses on how we can securely encrypt and decrypt messages using a simple but very powerful technique called the one-time pad.
Is also known as a OTP. It is a one method which is used to keep the message completely secure. It uses random keys to encrypt and decrypt the message. The important rule is that the key must be completely random and it is used only once and same length as the message. Conditions are followed, then the OTP is going to provide perfect security, meaning it is impossible to break. Coming on to the problem statement, in this topic, we are going to build the completely OTP encryption and decryption system. This system will generate a random key and encrypt the message and again decrypt it by using the same key. And we use XOR operation for this process. This shows that the OTP is mathematically unbreakable when it is implemented correctly.
Now I will explain the objective of our topic. The main goal is to implement a secure encryption technique using one-time pad method. This is important because perfect secrecy depends on randomness and equal key length. Next, we encrypt the plain text using the XOR operation with the generated key. The same key is then used again to decrypt the ciphertext and retrieve the original message. Finally, this demonstrates secure communication using one-time pad encryption, showing what proper key management ensures confidentiality of data. Now let's understand the mathematical concept behind the system, which is an XOR operation. C is equal to P XOR K and P is equal to C XOR K, where P represents the plain text, K represents the key, and C represents the ciphertext. XOR works in a very simple way. It gives 1 when the bits are different and 0 when the bits are same. First, we generate a truly random key that is exactly the same length of the plain text message. The important property of XOR is that using the same key again reverses the operation, which allows us to decrypt the message perfectly.
Now I will briefly explain how encryption and decryption work. First, let me talk about the encryption. We take a original message which is called plain text, for example confidential. Then we convert message into binary format because our computer only understands zeros and ones. Next, we generate the random key of the same length as the message. Now we apply XOR operation between the message and the key, bit by bit. The result we get is called ciphertext. This ciphertext looks completely random. The original message is hidden and secure. Now coming to decryption. To get the original message back, we take the ciphertext and the same key. Again we apply XOR operation. Since XOR reverses itself, we take back the original plain text. So finally we recover our message confidential exactly. Now let us see the example for encryption and decryption process. First we convert each letter into binary. So each characteristic becomes a sequence of zeros and ones. Next we take the key of same length. In our example we use XMCKL. Now comes to the main step encryption. We apply an XOR operation between the each letters of the message and the key. So basically H is XORed with X, E is XORed with M, L is XORed with C, and so on. After applying XOR to all characteristics, we get ciphertext. This ciphertext looks completely random, so no one can understand the original message just by seeing it. Now let's see decryption. To get back the original message, we again apply XOR operation between the ciphertext and the same key. and because XOR reverses itself, we get back HELLO. So finally, we recover the original message hello perfectly.
This Python code demonstrates one-time pad encryption using XOR operation. First, the plain text message confidential is converted into the binary format. Then the random binary key of the same length is generated. The program performs XOR between the binary message and the random key to produce ciphertext. For decryption, the ciphertext is again XORed with the same key which recovers the original binary message. Finally, the binary data is converted back into text, displaying the original message confidential. This shows how the OTP provides secure encryption and decryption using a single random. The conclusion is one-time pad uses XOR for encryption and decryption. The random key is used to recover the original message, making OTP highly secure and theoretically unbreakable.
Thank you so much for watching our presentation. We hope you find it easy to understand and informative.